So this review is going to be on related rates. We're going to start in Barron's on the first test, number 42. It says the hypotenuse AB of a right triangle ABC is 5 feet and one leg AC is decreasing at a rate of 2 feet per second. The rate in square feet per second at which the area is changing when AC is 3 is. Okay, so this is definitely a related rate problem. I have a right triangle. Hypotenuse is 5 feet. Tells me that one of the legs, AC, is 3, but that's after it's changing. That's not a constant. So you can't plug that in until after you've taken the derivative. But they are expecting you to know that when you see the hypotenuse of a triangle being 5 feet, that you know that this is a 3, 4, 5 triangle. Okay, so I'm going to do my work on a separate screen just so I have more room. Start by drawing my triangle. And it says the hypotenuse AB. So I'm going to let him be AB, let this guy be C. And it tells me that the hypotenuse is 5. I need something to label for my other side, so I'm going to let this guy be X and this guy be Y. If we go back and read, it says one leg AC is decreasing at a rate of 2 feet per second. So AC is decreasing at a rate of 2 feet per second. So that's dy dt, and it's decreasing, so it's negative. So negative 2 feet per second. It says the rate in square feet per second at which the area is changing. So I want the change in the area when, and then it says when AC equals 3, and AC is my Y, so when Y equals 3. Okay, so that takes kind of everything that they gave us in the problem and labels it and kind of puts it in terms of math. Okay, well, if I want dA dt, then I need a formula for area. Well, the formula for the area of a triangle is 1/2 base times height. So for us, that would be 1/2 x times y. But again, I don't want a, I need dA dt, so I need to take the derivative. And then I don't know if you guys remember, but when I taught this, we struggled with remembering that this is the product rule. And I am differentiating with respect to t, so this is all implicit, and it's a product rule. I'm going to pull my 1/2 out front, just kind of leave him sitting out there for a little bit. So then if I take the derivative of x, so that'd be a 1, but then it'd be dx dt, and then the y, plus, and then leave the x alone and take the derivative of y, which would be a 1, dy dt. Okay, so now that I've taken the derivative, now I can sort of plug in this when y equals 3. So dx dt, I don't know. Y is 3. So I don't know this. So we'll highlight him with red so we know we need to find him. X we actually know. When y is 3, again, you're supposed to know this is a 3, 4, 5 triangle. But if you know that y is 3, you can do the Pythagorean and do 25 minus 9 and get 16, and that's how you get the 4. So I know that my x is 4, but again, those 3's and 4's can only go in after you've taken the derivative because those values are changing. And then dy dt, it gave me from the get-go, so that's a negative 2. Okay, so the only thing that's in between us and our answer is figuring out what goes in this little red circle. So I need dxdt. Okay, well, if I need dxdt, I need a formula that has an x in it. Okay, well, we haven't done anything with the fact this is a right triangle. So let's go off to the side and make a Pythagorean theorem. So we have x squared plus y squared equals 25. And I can take the derivative of this. So that would be 2x dx dt plus 2y dy dt equals 0. I know x is 4. I don't know dx dt. That's what I'm trying to find. I know that y is 3. And I know that dy dt is a negative 2. So that would be 8 dx dt minus 12 equals 0. Add the 12 over and divide by 8 and reduce and get 3 over 2. So now I know him. And a lot of times that's what happens. You have a main formula that finds what you want, but inside of that you have this piece that you don't know and you have to kick out to the side and find another relationship to find that one piece. So it's sort of like a sidebar equation. So if I want dA dt, now all I have to do, let's see, that'd be 9/4 minus, not 9/4, sorry, 9/2 minus 8. Let's see, that's 16 over 2. So that would be negative 7 over 2. And that would be negative 7 over 4. So dA dt equals negative 7 over 4. And then if we go back to the problem, negative 7 over 4. So think about too, why is it negative? Well, if one of our legs is decreasing at a rate of 2 feet per second, that's going to make our area also decrease. And again, the nice thing about the video is you can watch it once to do it, but then you can always go back and watch it again just to watch it and let it sink in. The more you see of these, the better off you'll be. Here it's number 44. It says the radius of a sphere is increasing at a constant rate. Then the rate of increase of the volume of the sphere is, okay, well, this isn't really asking us to find any numbers. You do have to know the volume of a sphere, and that's 4/3 pi r cubed. Okay, and it says the radius is increasing at a constant rate, then the rate of increase of the volume. Well, the rate increase of the volume would be dV dt. So I'm going to go ahead and find a formula for that. Pull the 3 down, that'd be 4. This is not a product, dr dt. This is not a product formula because it only has one variable in it, because remember, pi is a constant. That makes it a lot easier. Okay, now it says that the radius is increasing at a constant rate. Okay, so that tells me that this right here is a constant. Okay, well, so is this. So if I put these two things together and they're constant, then I have dV dt equals some constant r squared. And in this constant are my 4 pi and my dr dt, which they said was constant. Okay, so now it says, then the rate of increase of the volume. Okay, so well, this is the rate of the volume. And look, if I'm plugging numbers in for my r, they're getting squared. So yes, it's increasing, but is it increasing constantly? Like the same amount, like when I plug in a 4 or I plug in an 8, is it increasing the same amount every single time? Is it increasing at an increasing rate, a decreasing rate, increasing for certain R's and decreasing for certain and increasing? Let's look at this. No matter what you plug into R, whether it's positive or negative, and then you square it, think about what that's doing. That's increasing at an increasing rate. As R's get bigger, this value right here is going to get bigger faster. If I plug in a 1, then I'm just multiplying this by 4. But if I plug in a 4, I'm multiplying this by a 16. If I plug in a 10, I'm multiplying it by 100. So as you plug numbers in for your R, this is increasing at an increasing rate. I don't have to worry about what my values of R are because I'm squaring it. And it will always be increasing. Okay, the next one we're headed to is Barron's 2, number 5. Barron's 2, number 5. It says air is escaping from a balloon at a rate of, in cubic feet per minute, where T is measured in minutes. How much air in cubic feet escapes during the first minute? Okay, so first of all, this formula should look familiar. It's not one that we just like really crazy went hardcore and tried to memorize, but it's one of those that you need to know he exists. And this is the one that pops up the most. So if you can't think about what it is, look back at your formula sheet. The other thing I want to point out is it is telling us that air is escaping from a balloon at this rate. So this is not R, this is dr dt. This is the rate at which it is escaping, and that's what it says. So they're giving to this as R of t, but you need to think of that as dr dt. So this is already the derivative. So if I've already done the derivative, then I want to know what happens in the first minute. How much air in cubic feet escaped during the first minute? Well, so you really want to take the integral. I want the integral from 0 to 1 of 60. How much air in cubic feet escapes during the first minute from 0 to 1? Okay, so now I hope you figured out what this formula sort of looks like. This is your little tangent guy. So you need to figure out what A is, and you need to figure out what U is. So use your formula sheet. A is going to be a 1, U is going to be a T. Okay, so I have everything. I have this extra 60 though. So I'm going to pull him out. And then I'm going to do 1 over 1 tangent inverse T over 1. That's your U over A. And then I'm evaluating it from 0 to 1. So again, the 60 is just chilling. This is tangent negative 1 of T. Just get rid of all the fluffy stuff. Okay, so now I have 60 tangent inverse of 1 minus tangent inverse of 0. Okay, now remember what tangent inverse means. Where is tangent 1? Well, that happens at pi over 4. Where is tangent 0? Okay, think about it. This would be 1, 0. Tangent is y over x. Is that 0 or is that undefined? That would be 0. So it happens at 0. Well, pi over 4 minus 0 is pi over 4. And 60 times pi over 4 is 15 pi. Okay, now we're going, same test, we're going to number 42. Okay. Suppose f of x for x is greater than 0 and x is increasing, the value of x for which the rate of increase of f is 10 times the rate of increase of x. Okay, well let's get some df's and some dx's in here because that represents the rate of increase of f and the rate of increase of x. Okay, so here we go. I have f of x equals 1/3 x cubed plus x. Okay, so if I'm going to differentiate this, I'm going to call this df dt instead of f prime, just so it kind of all looks the same. And then this is going to give me, pull the 3x squared plus 1. And then I'm going to just do a dx dt on the end instead of doing one for each of the terms. Okay, now it says I want the value of x for which the rate of increase of f, okay, that's him, so df dt is 10 times the rate of increase of x. That's that right there. Okay, so hopefully that makes sense. Okay, well, so what do I need to set equal to each other? Well, look, this is right there, this is right here, but I have this piece right here, and I have this piece right here. So I'm going to take x squared plus 1, set it equal to 10, and solve it, and that's going to give me what x is. So subtract 1, root both sides. Now I have plus or minus 3, but it tells you that x has to be greater than 0. So we're going with 3. Okay, the next one we're going is Barron's 3, number 30. Barron's 3, number 30. Okay, we have a cylindrical tank shown in the figure above. Looks like a septic tank. Partially full of water at t equals times 0. So we're partially full of water right here, and that's t equals 0. So this is how much we have in it so far. Okay, here's t equals 4, and here's t equals 12. It'll be full. Okay, the tank becomes half full when t equals 4. Okay, I can see that. That's halfway. And it's completely full when t equals 12. Yep, okay, got that. Let h represent the height of the water. Okay, so right now this is my h, and then that would be at time 4. That, so the height is just the height. During which interval is dh dt increasing? Okay, so during which interval is the change in the height increasing? Well, the height's always increasing. That's this. That just means that dHdt is positive. It is increasing. But this is saying, when is it increasing faster, at a faster rate? Okay, well, guys, think about this. We're gonna put some water in here. Here it goes. Here goes all the water, okay? And it starts to fill up. Okay? What happens when we cross 4? Think about what's left, the space that's left. As you fill in water at the same rate, isn't the height gonna get taller faster once you cross midway? Because this tank gets smaller, what's left of the tank gets smaller as the water level rises above halfway. I don't know if I'm explaining that really well, but it takes more time to go from here to here than it does to go from here to here. So the height of my water level, and when you get right here at the top, it's going to fill up like super fast because there's very little area left of the tank because it's on this rounded shape. Okay, now let's take all this off so you can see it again. So it's gonna fill up really slow at the beginning because the area is getting wider. It's still getting wider. So this is actually increasing at a decreasing pace. increases really fast down here at the bottom, and then it really starts to slow down because it's got so much volume to cover in this tank. But as soon as you cross halfway, think about what happens. Okay, so this should be it should peak at its slowest speed right here. H is increasing. And then it should bloop, finish really fast right there at the end. So the height is increasing, or the change in the height should be increasing really quickly from 4 to 12. Anything over halfway. Okay, so let's see, that was Barron's 3. So now we're headed to Princeton 132. Princeton 132. This is a great classic related rate problem. Boats A and B leave the same place at the same time. Boat A heads due north at 12 kilometers per hour. Boat B heads due east at 18 kilometers per hour. After 2.5 hours, how fast is the distance between the boats increasing? Okay, well, y'all know I love to draw a good picture. Okay, so here we go. Here are the boats. Now, boat A is headed north. So here's boat A, and here's boat B. And here's boat A's distance, and there's boat B's distance. And I'm interested in how far apart they are. I'm going to call that X. C, whatever. I'm going to call it X. Okay, now I'm going to write what I was given. So let's see. It says boat A is going 12 kilometers per hour. That's a speed, so that is his rate of change. So dA dt is 12. Positive because the distance is growing. B is going 18, going a little faster. I want the distance between the boats. I want dx dt, that's a t, when, how long? 2.5 hours, not x. When t is 2.5 hours. Okay, so obviously we have a nice little Pythagorean triangle, Pythagorean theorem going on here. So I have a squared plus b squared equals x squared, because I used x instead of c. Okay, so I'm going to take the derivative of this and get all kinds of stuff. So 2a dA dt, 2b dB dB dt equals 2x dx dt. None of these are constants. These are all changing. It's not like a ladder. Every one of these distances is growing. Okay. So let's see. As of right now, I want him. That's what I want. I know this guy, and I know this guy, because they're right there. I don't know him or him or him. Okay, so let's think. 2.5 hours. Okay, well, I've already taken the derivative. So these are, this a, b, and x. These are now distances at 2.5 hours. So if boat A is headed north at 12 kilometers per hour and I've gone 2.5 hours, we know how far boat A has gone. A is 2.5 hours and he's going 12. That makes a 30 kilometers out. B's going 2.5 hours and he's going 18. That makes him 45 kilometers. Okay, all right, now we're getting somewhere. So let's see. I've got 2 And A we said was 30. dA dt was 12. B was 45. dB dt was 18. Okay, well, I still don't have x. Okay, hold on a second. I know this. And if I know A and B, I can plug them in here to find x. Okay, here we go. So A squared plus B squared equals x squared. So square those, add them together, and then square root it. I got 54.0833. And they always tell you to go 3 decimal places. I'm going to go 4 because of the 0. So now I can plug 54.0833 times dx dt. And again, that's what I'm looking for. Okay, awesome. So now we just number crunch. So you're going to do all of this plus all of this, and you're going to divide it by those two guys. Now remember, when you divide, if you're dividing by two things, make sure you put both those things in one set of parentheses to make sure it puts both of them on the bottom. So practice typing that in, and you should get 21.633, which is that guy. Make sure that you're really comfortable and understand the fact that I couldn't have found these guys and plugged them in before I took the derivative, because this 30 and this 45, they're not constants. So they can't go in until after you take the derivative. That was a really, really good fine-tuned detail from when we did related rates that seemed to pop up a bunch with some issues. So make sure that you're really, really comfortable on that. And again, write it all out, get it all good, and then go back and just listen to it one more time just to make yourself feel a little better about it. Okay, the next one we're going to is number 41, same test. Okay, so it says use differentials to approximate the change in the volume of a sphere when the radius is increased from 10 to 10.02. Okay, you see that word approximate, you almost want to use your approximation formula. Same concept, but we're not going to use that formula. At first, I need the volume of a sphere. And it says I want the change in the volume. Okay, so I need dV dt. These are all constants, so this is not the product rule. This is just a power rule. Okay, so this is kind of cool because it's really, really simple. I want this when the radius goes from 10 to 10.02. Well, what's this 0.02? Well, that's your dr dt. That's the change. That's how much it's increasing. So for pi, what was your radius to start with? It was 10. And what was the change in your radius? That's kind of what he is. What's it growing by? And then you type all that into your calculator. Done. Easy. It's just making sure that you understand what dV dt represent and what dr dt represent, and how you take the derivative, and do you know your volume formula? Okay, let's see. Now we're headed Princeton 237. Princeton 2, number 37. On the classic ladder problem. Okay, here we go. Just a minute. Let's try that again. Okay. I have a 20-foot ladder. Constant, does not change. The ladder is not increasing or decreasing. That's a constant. He can go in from the get-go. In fact, he has to go in from the get-go. Now this ladder is sliding down the wall at 5 feet per second. Okay, so I'm going to let him be x and him be y. Now that does not tell me that x is 5. That tells me that dx dt, and it's not just a 5, it's a negative 5 because that height is getting smaller. At what speed is the bottom sliding out? Okay, so I want dy dt when the top is 10 feet from the floor. Will that be x? When x is 10. Okay, so we're going to base this off of the Pythagorean. So x squared plus y squared equals z squared. Now, before you take the derivative, do you have any constants? Yes, this right here. Now, this when x is 10, that's not a constant because that's after it's slid for a while. I want to know what is the change in y when x is 10. But the x is not always 10, so it can't go in at the beginning. So make sure that's really, really clear. So now I'm going to take the derivative. So 2x dx dt plus 2y dy dt equals, now be careful here, what's the derivative of 400? 0. Okay, so now let's plug some stuff in. 2, let's see, told me x is 10. I can plug this in now. Ask yourself why. Because I've already taken the derivative. dx dt, it told me, was a negative 5. Do I know why? I do not know why. Do I know dy dt? Nope, that's what I want. Okay, so now here's sort of my framework. I have this one piece of information that I don't know. I don't know why. And I want y not as a constant from the original, but I want y after I've taken the derivative. Well, I know that x is 10, and I know that my hypotenuse is a 20, and that's a constant. So 10 squared plus, I don't know, equals 20 squared, which is 400. 10 squared is 100. So y equals 300, or y squared equals 300, so y equals 10 root 3. So 10 root 3. Awesome. So now I can solve for dy dt. So let's see. 2 times 10 is 20. 20 times negative 5 is negative 100. Plus 20 root 3. dy dt equals 0. I'm going to add the 100 over. And then I'm going to divide. All my answers are decimals. I'm going to type this in very carefully, making sure that you put parentheses around the bottom because those are two things. And I get that my dy dt is 2.887. Okay, we talked when we did related rates. We talked about how the ladder problem is a golden go-to, gonna see it every time kind of problem. This is also a great free response question because there are a bunch of different steps, and they could ask you different things about it. Okay, so now we're headed Princeton 333. Princeton 333. This is another great problem. It's really straightforward. Just making sure that you understand related rates and what the rate of change is. Okay, so it says the side of a square, all sides are the same, is increasing at a constant rate. That's telling me that dx dt is 0.4. In terms of the perimeter, okay, let's stop. Perimeter of a square, all four sides added together, that'd be a 4x. In terms of the perimeter, what is the rate of change of the area? Okay, stop. Now it wants area. Area of a square is x squared. What is the rate of change of the area? So I want dA dt. Okay, so that tells me which of these formulas I need to take the derivative of. If I want dA dt, then I need to take the derivative of this guy. Okay, well, let's see what it gave me. It gave me dx dt. So dA dt equals 2x times 0.4. Okay, and then it says, let's see, in terms of the perimeter. So you see how all your answers have p's in them? My answer right now has an x in it. It doesn't say it wants it in terms of x. It says it wants it in terms of the perimeter. Well, what the heck do we have to find this guy for? Like, why did it talk about perimeter? Take this equation right here, solve it for x, and that'll be in terms of p, and I can plug it in there for x. So x equals p over 4. So now take this and put it there. So dA dt 2 times p over 4 times 0.4. So do 2 divided by 4 times 0.4, and you get 0.2 p. You just have to think very literal, very logical when doing that problem, when doing most of these problems. Okay, last one we have to look at is on the extra practice, and it's number 98. Extra practice number 98. If a block of ice melts at the rate of 72 over 2t plus 3, how much ice melts during the first 3 minutes? Okay, wasn't there one we just did where it was something that happened in the first minute? Well, this is the first 3 minutes. Now, it's telling you that this is the rate at which the block of ice is melting. So this is, I don't know, we'll call it I for ice, d ice dt. That's the rate at which it's melting. So that's already the derivative. I want the first 3 minutes. So I want the integral from 0 to 3 of 72 over 2t plus 3. Now this might make you think of the tangent inverse guy, but he's not because nobody's squared. You need to be thinking ln here. If you do a little u substitution, let your u be the 2t plus 3, what's on the bottom. Your u prime would be a 2. Well, I have a 2. Well, I have a 72. So if I pull the 2 out, that would leave me with an extra 36. So I'm going to pull the 36 out, and I'm going to write it just so y'all can see it. So now that's this, which is u prime over u, which is ln. So 36 ln, and I'm going from 0 to 3. So 3 minus ln of 0. So 36. Oh, no, sorry. I forgot to put my u back in. So sorry. ln of 2t plus 3. Now let's go from 0 to 3. My bad. Okay, so ln of, plug your 3 in there, that'd be 6, that'd be a 9, minus, plug your 0 in there, that would be ln of 3. And then you just type, and I typed it all in one swoop. Just watch your big parentheses with your 36 on the outside, or you could just do ln of 9 minus ln of 3, get that answer, and times that by 36. I got 39.55. So I'm going 40.